Okay, friends, it is time to start diving into multiplying decimals. This is something we really haven't talked about together yet. I know I assigned you some videos and work to do in Envisions last week on multiplying decimals, and now we're going to start talking about it together and trying to make sense of what it means to multiply a decimal by a whole number or by another decimal. One thing we want to remember when we're multiplying decimals is that decimals and fractions both represent a value of something that's less than one whole. So sometimes if the decimal part doesn't make sense to you, if you try to think of the story problem in terms of a fraction and vice versa, it might make more sense. So here's an example that will help us to do that. Okay, so here's our story problem. A bakery is making a big batch of muffins, and their recipe for banana oat muffins calls for 4/10 of a kilogram of old-fashioned oats. Now, when we think about a kilogram, we're talking about something that's pretty close to a pound. So if you imagined like a pound of flour or a pound of sugar or a pound of oats to make banana oat muffins, a kilogram is pretty close to that. And this recipe calls for a little less than half a kilogram, 4/10 of a kilogram. So if we imagine that this decimal grid here represents one whole kilogram, if we shade in 4/10 of this, that'll be how much their recipe calls for. So let's do that. Here's 1/10 of a kilogram. And remember, these little squares represent oats. 2/10 of a kilogram. Sorry if this is boring. I don't know how to speed up the speed of my video. That's a YouTube skill I don't possess. 3/10 of a kilogram and 4/10 of a kilogram. Now, if you have these decimal grids at home, I sent them to your parents a while ago. These would be good to print out and kind of shade along with me. All right, so there's my 4/10 of a kilogram. You can see it's a little bit less than a half a kilogram. And then they tell us that the bakery is only going to make half that recipe. They're not even going to make the whole recipe. They're making 1/2 of 4/10 of the kilogram of old-fashioned oats. So in decimal form, that would be 1/2, which is 5/10, of 4/10. And this word of, I haven't thought of a really great way to explain this to you. The word of is important here because it tells us we need to multiply. It's kind of like when we're looking at whole numbers, if we have like 3 groups of skateboards, how many wheels do we have? So then you have to multiply. Or if we have 4 groups of a dozen eggs, we know we have to multiply. There's something about that word of that always just signals to me, hey, we're going to multiply. And I have to admit I haven't thought of a really great way to explain why that is to you, but it just is. Whoops, I wrote that wrong. So we're going to do 5/10 or half of 4/10 of a kilogram of oats to figure out how much they need. So now in order to do that, I'm going to shade in 5/10 of my 4/10. So it's a portion of my 4/10 that I already have. I have already shaded in my 4/10. Now I'm going to shade in a portion of that, 5/10 of that. So here's 1/10 going side to side, 2/10 going side to side, 3/10 going side to side, 4/10 going side to side, and 5/10 going side to side. So now I can look at this and say, okay, what is half of 4/10? it's less than what you would think, right? Let's see, 1, 2, 3, 4, 5 hundredths. So 5 hundredths, 10 hundredths, 15 hundredths, 20 hundredths, or 2 tenths is what I'm counting up. 2 tenths. Because this is a group of 5 hundredths, and this is a group of 5 hundredths. 5 hundredths plus 5 hundredths, we bundle that together to 1 tenth, and then 15 and 20. All right, so the model that I want you to use for multiplying fractions like this, or multiplying decimals like this, is to shade your decimal grid up and down, shade it going vertically first, and then shade it going horizontally, side to side, and your overlap is your product. Your overlap is your product. I'm making a mess of my diagram now. Let's look at another example and see if it makes sense. Okay, here's another example. Miss Lynn bought a half-pound bag of candy to share with her students. So I always like to draw a picture for these types of problems. That's supposed to be a bag. And it weighs 1/2 of a pound, which we can represent like this. 5/10 of a pound is the same as a half. LB stands for pound, okay? 1/2 a pound. And on the way into school, I spilled 3/10 of the bag. I spilled some of it on the ground. Can you believe I did that? Why would anyone waste candy like that? And I want to try to figure out how much of my candy I spilled. Now, my decimal grid is going to help me do this. Okay, so here's my decimal grid, and I need to show 3/10 of a half-pound bag of candy. So that's going to be 3/10 times a half-pound bag of candy. I'm going to shade 3/10 first. 1, 2, 3/10. And then I'm going to shade 5/10 going the other way. 1/10. 2/10. 3/10. 4/10, and 5/10. Now, where those two areas overlap is my product. So this is what it looks like when I spill 3/10 of my half-pound bag of candy. What I dropped on the ground was, let's see, 1, 2, 3, 4, 5/10, 10/10. I'm sorry, I said that wrong. 1, 2, 3, 4, 5 hundredths. 6, 7, 8, 9, 10 hundredths, which is 1/10. 11, 12, 13, 14, 15 hundredths. So 3/10 times 5/10 equals 15 hundredths. And if that's confusing to you, I don't want you to stress. For now, all I want you to remember is this magic word of tells us we need to multiply. And then use your decimal grid, shade your first factor going up and down. Here's your first factor. Shade your second factor going side to side. And then the overlap is your product. That's all you need to know for now, my friends.